Good evening, everybody. It's Tuesday, March 17th, and this is Nighttime Mathematics Radio. Coming to you live from our secret headquarters by the Bay, bringing math to a nation full of shut-ins, where the math homework goes on, but the schools are closed. If you have any questions, feel free to ask them on Twitter. Just tweet your questions to @NightMathRadio. I'll try to answer them here live on the air. So let's take about 2 minutes here listening to Apple's strangest loops. When we come back, we'll see if anybody's asked any questions on Twitter. If not, we'll answer one of the questions that came up earlier in the evening. Somebody's wondering how you're supposed to know all those trig functions that you are just sort of expected to somehow understand. That sine 45 degrees is root 2 over 2. That tangent of 60 degrees is root 3. How do you know these things? We'll talk about that right after the break. This is Nighttime Mathematics Radio. Welcome back, everybody. This is Nighttime Mathematics Radio. We'll try to answer your questions as they come in on Twitter, live here on YouTube. So, for the moment, let's start with the question that got asked earlier. Somebody was wondering how you're supposed to know all those trig functions that you're just sort of somehow supposed to know. You're supposed to know what sine of 30 degrees is. You're supposed to know what cosine of 60 degrees is. You're supposed to know what tangent of pi over 4 is. What are these things? How are you supposed to know them? The answer is that there are two very special triangles that come up so incredibly often that it's really worth knowing how to quickly draw them, quickly find your way around them. If you could do that, you could pull out all these trig functions almost immediately. So let's take a look at them. Now, one of these special triangles comes up when you start with a square. And it doesn't matter how big a square is, it turns out. Because remember, trig functions are just ratios. So it doesn't matter how big we make them as long as we get all the ratios right. So let's start with a square. We can all agree to pretend that's a square. My artistic skills aren't all that. Of side 1. So it's 1 on every side. And now let's cut that square in half down the diagonal. Now, when you do that, you end up with a nice little right triangle here. That's still a 90-degree angle because it was a square. And each of these angles are now 45 degrees. Now, remember, 45 degrees is an eighth of the complete circle. And that's where radians come in. When you're talking about radians, you say, well, the entire circle is 2 pi. Because radians are just arc length divided by radius. And remember, the full circumference is 2 pi r. So the full circle is 2 pi r divided by r, just 2 pi. So So this is 1/8 of a full circle, so it must be 2 pi divided by 8. Or pi over 4. So pi over 4 and 45 degrees are the same thing. So then the question is, how are we supposed to figure out trig function of these things? Well, first of all, we've got each of the short sides. They're both 1, because those are the sides of the square. So the only question left is, what's this long side? What is this length? Well, we could call it c, and then we get it from Pythagoras' theorem, because this is a nice right triangle. So we get c squared is equal to a squared plus b squared. So that's equal to 1 squared plus 1 squared. Well, 1 squared is 1 in each case. So 1 squared plus 1 squared is just 2. So c squared is 2, and c is the square root of 2. This is the classic 45, 45, 90 right triangle. I'll redraw it over here, just rotating it a different way. Each of these angles is 45 degrees. The short sides we could think of as length 1. Again, we could make them s or 2 or 53. It doesn't matter, because all we care about is ratios. And this side is the short side times root 2. Now, once you can draw this very quickly, and you can see it's pretty easy to draw. This wasn't any heavy lifting math. This is stuff you could have done since Algebra 1, as soon as you learned Pythagoras' theorem. Now you can see what all the trig functions are for 45 degrees, or for pi over 4. Do we want to know cosine? Well, that's got to be adjacent, 1, divided by the hypotenuse, which is root 2. And so the answer is 1 over root 2, but there's a problem. And the problem is, we have to figure out a specific way to write numbers like this. If we write them down any which way, you could find a lot of numbers that are exactly the same but look different. And that means that it's going to become really, really difficult to simplify expressions, for example, which is something we want to do all the time. And so centuries ago, the decision was made, if you have an expression like this with radicals in it, put all the radicals in the numerator. That will give you a single way of writing the number down. So how do we do that? How do we change 1 over root 2 into a number that has the radical in the numerator? And the answer is, well, we can multiply by the square root of 2 over the square root of 2, because that's just 1. It's not cheating to multiply by 1. Multiplying by 1 just gives you the same number you had to start with. So I can multiply by that. 1 times root 2 is root 2. Root 2 times root 2 is root 2 squared. Remember, when I say root, I mean the square root. That thing, if you square it, will give you 2. So the square root of 2 times the square root of 2 is the square root of 2 squared, or 2. And this is the classic way you see cosine of 45 degrees written. It's square root of 2 over 2. Likewise, playing exactly the same game, you'll see that sine of 45 degrees is also square root of 2 over 2. It has to be, right? Because there's no way you could tell which angle you're looking from. And you get the same ratios. I mean, is this 1 over root 2 adjacent over hypotenuse from this 45 degrees, or is it opposite over hypotenuse from this 45 degrees? So the sine and the cosine are exactly the same here, which makes perfect sense. Then finally, we say, well, what about tangent? What's tangent of, and just to mix it up, I'll say pi over 4 this time. It means exactly the same thing. The answer is that's opposite over adjacent, so that's 1 over 1, which is better known as 1. So there's all the trig function's values at 45 degrees. You can get them all just off this triangle. What does that mean? It means if you're in a trig class, or you're in a physics class, or you're in a pre-calculus class, or you're in a calculus class, and you need to know these trig functions, if you could remember how to draw this triangle very, very quickly, and you'll get a lot of practice doing that because these numbers come up all the time, then you can quickly figure out what all the trig functions are without having to even think about it. Then the question comes, oh, well, this is all great, but why don't I just use a calculator? Here's a calculator. Why don't I just use this? And the problem here is, and let's double check, we are in, the calculator says we're in degrees mode. It says deg up there. I can say, give me the tangent of 45 degrees, and it's 1. You say, perfect. I don't need to learn anything. Why am I even talking about this? Well, I type sine of 45 degrees, and it gives me a decimal expansion. It gives me 0.7071. And yes, that's really close to square root of 2 over 2. I mean, we can figure out square root of 2 over 2 here if we have to. 2 square root divided by 2 equals 0.7071, so that is in fact it. The problem is this is much harder to work with if you're in a hard algebra problem, or especially as you move on in math, in a hard pre-calc question, a hard calculus question, a hard physics question, a hard mechanical engineering question. These are going to be really hard numbers to work with. So we usually want to save these for the very end of a problem. You usually don't want to jump to decimal approximations midway through a problem, because it just makes your life much harder. So it's much, much easier to instead just learn how to get this triangle, write it down as square root of 2 over 2, and then do algebra, because algebra is easier than arithmetic. When you're doing arithmetic, you have to plug lots and lots of numbers into a calculator, and it's easy to get that wrong, especially if you're doing it step after step after step after step. It's much better to do algebra where you're not going to make easy mistakes, and then at the very end, plug into your calculator if you need to. Okay, that's 45 degrees. That's pi over 4. What about the other ones? The other ones that come up all the time are pi over 3 and pi over 6, or in degrees, 60 degrees and 30 degrees. Well, there's a second special triangle that comes up all the time. And the way you generate this one, start with an equilateral triangle. So here's a nice equilateral triangle. You know the interior angles of a triangle add up to 180 degrees. And that, since it's equilateral, they all must be the same. Because an equilateral triangle is also an equiangular triangle. So make the sides 1 for simplicity, just like we did with the square. Let's cut it in half, just like we did with the square. Now, this length down here, well, that cut, if I were any sort of artist, that would have cut the bottom half exactly in half, so this would now be 1/2. What about this third leg? Well, it's back to Pythagoras' theorem. We know that c squared is equal to a squared plus b squared. C squared is 1 squared. A squared, this side we know, is 1/2 quantity squared. And b squared is the thing we're looking for this time. Because notice this isn't the hypotenuse. Here's the right angle. The hypotenuse is 1 this time. That's easy. So let's square these out. 1 squared is 1. 1/2 squared is 1/4. Because remember, 1/2 times 1/2, when you multiply fractions, that's the easy one, where you just multiply the numerators and multiply the denominators. Plus b squared. So b squared is equal to 1 minus 1/4. And that should come as no surprise, that's 3/4, because 1 is 4/4. So square rooting both sides, b is equal to the square root of 3 over 2. And this is in the form that we expect for a rational expression, for a radical expression. The radical's up in the numerator where it belongs. So now we've got our root 3 over 2 over here. And we know these angles. This is 60 degrees, because that was one of the original angles of the equilateral triangle. This is one of the angles cut in half. So this angle here is 30 degrees. And if we want to put these in terms of radians, well, what is 60 degrees? 60 degrees is 1/6 of a full circle, because a full circle is 360 degrees. And 360 divided by 60 is 6. So that's 2 pi divided by 6, or pi over 3. And this is half of that, so that's pi over 3 divided by 2, which with a little bit of fraction math you can realize is pi over 6. Makes sense, right? This was 1/6 of a full circle. This is 1/12 of a full circle. So this is 2 pi divided by 12, or pi over 6. And once again, you can now read off all of the trig functions. What's sine of 30 degrees? And because I'm sleepy and don't feel like drawing pies, I'll do it all in degrees for the moment. Sine of 30 degrees is 1/2 divided by 1. Now you have to be careful, because remember, before we hardly had to be careful because both angles are 45 degrees. Here you really have to pay attention to which angle you're looking from. From this angle, opposite is 1/2. Adjacent is 1, so 1/2 divided by 1. That's dividing anything by 1 is easy. That's 1/2. So that's sine of 30 degrees. How about cosine of 30 degrees? That's the square root of 3 over 2, the adjacent one this time, divided by, again, 1. So that's the square root of 3 over 2. So once again, once you draw the triangle, once you remember how to make this triangle, and you can learn how to do that very quickly. There's nothing fancy going on there. That's all fairly straightforward math. You could just read off all these trig values that otherwise you have to memorize as symbols, which is much, much harder. Now, to be clear, eventually you really do want to memorize these things. But it's much easier to memorize something that you know how to get if you forget. It's hard to memorize something completely random by just sort of trying to jam it into your brain by reciting, sine 30 is 1/2. Cosine 30 is pi over 2. It's not pi over 2. You see, this is where you get wrong, because if all you have is random symbols in your head, one sounds just like another. Whereas if you could hear yourself getting backed up, you could always go back and draw the triangle again. So it's much, much easier to memorize these things after you've drawn the triangles. How about tangent of 30 degrees, as long as we're at it? Well, that's opposite, 1/2, over adjacent, 3 over 2. And you look at this going, wow, that's a horrible expression. How do I do that? Relax. Remember, a fraction bar means the same thing as division. So this is just 1/2 divided by √3 over 2, which is 1/2 times 2 over √3. The 2's cancel. That's 1 over √3. And once again, centuries-old mathematicians made a choice that works against us for the minute here. 1 over √3 is not the traditional way of writing that number. So you have to multiply by √3 over √3 to get √3 over 3. And there's our tangent of 30 degrees. How about 60 degrees? Let's look at the 60 degree. Well, now we're over here. So sine of 60 degrees is √3 over 2 divided by 1, opposite over adjacent. But that's exactly the same thing as cosine of 30 degrees, right? Sine of 60 degrees is the same as cosine of 30 degrees, because from the point of view of the 60-degree angle, √3 over 2 is the opposite side, and 1 is the hypotenuse. But from the point of view of the 30-degree side, √3 over 2 is the adjacent side. So this sine of 30 degrees is the same thing as cosine of 60 degrees, and cosine of 30 degrees is the same thing as sine of 60 degrees. How about tangent 60 degrees? Well, that's got to be opposite over adjacent. Opposite is √3 over 2. Adjacent is 1/2. Once again, we write this as normal fraction division for 3 over 2 divided by 1/2, which is √3 over 2 times 2 over 1. The 2's cancel, and we just end up with √3. That's it. That's where all the standard trig functions come from. And so once you can draw these two triangles, so it's really worth your while if you're just starting out in pre-calculus or just starting out in a trig class. Or if you're in calculus and all these things have fallen out of your head, which happens all the time. Or worse, you did this years ago and now you're in a physics or an engineering class and suddenly you need to know these again. Practice drawing these two triangles, because that's where these values come from. Once you can draw these triangles, you're home free. This is Nighttime Mathematics Radio. Once again, if you have any questions on Twitter, feel free to tweet them in. I'll try to answer them here live on YouTube. So let's take about 2 minutes back, listening to some of Apple's strangest loops. When we come back, we'll answer another question. Welcome back, everybody. This is Nighttime Mathematics Radio. Well, it looks like the well of Twitter's run dry, and it's getting late here, so let's sign off for the evening. Anyone has any more questions, feel free to tweet them in. I'll try to answer them live on the air tomorrow. Once again, we're live every night at 9 p.m. See everybody tomorrow night. Enjoy the math, live through the shutdown, and we'll see how things go. See everybody tomorrow night, everybody.